Today, I'm going to show you guys a new way to make predictions using the regression line. And since our regression line is just a straight line right here, we know that it's going to have the form y equals mx plus b, which you may know as slope-intercept form. So here this is saying that for a value of y, that is equal to m, which is our slope, times an x value, plus b, which is our y-intercept. And y-intercept is just where the regression line crosses the y-axis. So in Chapter 7, we learned that the formula for slope was the correlation coefficient times the SD of y divided by the SD of x. So we know how to solve for n, our slope. We already learned that. Now we need to solve for our b to be able to make our predictions. And solving for b, our y-intercept, doesn't necessarily have that exact formula or a formula like the slope does. But instead, we're going to plug in values of y and x, and then we'll know our m in order to get that one last variable, b. So if we're given a list of numbers that has all of our y values and their corresponding x values, we can just pick any point. We can plug that in for our x and y. But if we're not given a list of numbers, what is one point that we know is always going to lie on the regression line? Yes?
Well, last time didn't we learn about something called like the point of averages?
Yes, that's exactly right. The point of averages, or as you can see right here on this graph, where the SD line and the regression line intersect, is always going to be on the regression line. So we'll always know that point, the average value of x and the average value of y, even if we're not given a list of x's and y's. So that's how we're going to solve for our y-intercept. We're going to plug in the average value of y, the average value of x, and then our slope, so we'll only have b, our y-intercept, remaining. So now we're going to look at an example where we use the regression equation to predict the number of likes you get on your profile picture from the number of Facebook friends you have. So our Stat 100 team here in the lab decided to take real life data and look at the number of friends we had and then the number of likes we had on our profile picture. And we saw from the graph right here that in general there was a pretty good correlation. The more friends you had, the more likely you were to have more likes on your profile picture. And again, we took real life data. For example, your Stat 100 professor, Ellen Fireman, has 521 friends and 29 likes on her current profile picture.
Wow, that's great. I didn't know I had that many friends. That's terrific. I used to have 0 friends. Really, I did. It used to say Ellen Fireman has no friends for many years. So I am really pleased and I want to find myself. So 521, can you see me? 521 is right about, is that me? Yeah, that must be me.
Yep, that looks like you, 521.
Where are you, Carly?
29. I have 424 friends and 17 likes, so I'm probably
you're
right here,
there.
right
Oh, we're
here.
pretty close to each other.
Yeah, you have more friends than me.
Who is
though.
this?
That is the football player. The football player had a ton of friends, and then also had a lot of likes.
And this poor person.
And that's the mother-in-law.
Oh,
They only had one like.
oh, okay. Whose mother-in-law? Yours?
No, Jackie's actually.
Okay. Well, go ahead.
All right. And speaking of Facebook, everyone should go to our Stat 100 Facebook page and be sure to like it. So again, here we're looking at predicting the number of likes on your profile picture from the number of Facebook friends that you have. And for part A, this is asking us to find the regression equation. Now, we said before that the regression equation is going to be in slope-intercept form. So it's going to look like this. Y equals mx plus b, where m is our slope and b is our y-intercept. So those are the two things that we need to find. So first, when we're finding the slope, we already know the formula for the slope of the regression equation. Does anyone remember what that formula is?
The standard deviations
it does have to do with the standard deviations.
Oh,
And it has to do with
R.
one more thing, R, right.
Which one goes on top though?
So,
Y over X.
Y over X, yeah, because we predict Y, Y over X.
right, so we have
R.
R times, like you said, SDY over our SD of X. So our correlation coefficient is 0.9. And now SDY. So how do we know which is our Y? The profile picture likes or the number of friends?
Isn't it what we're trying to predict?
Correct. So what we're trying to predict is always going to be our Y. Here, we're trying to predict the number of likes. So our SDY is going to be 16. And then our SDX is going to be the SD for the number of friends, which is 540. Now what does that come out to?
I got 0.02666667. Okay, so maybe we'll do 0.027.
Let's do 0.027, round to 3 decimal places. So this is our slope. So now we have one piece of the puzzle. We have our M. We want to find our B. And remember before we talked about, we know our M, and we're going to plug in a value of X and a value of Y into this equation to solve for B. So does anyone remember what I said, what point we're going to plug in for X and Y?
The averages, the point of averages.
The point of averages. So given this information, what's going to be the Y that we plug in?
Y is like, so it'll be 32?
Yeah, the average
Right.
for what we're predicting.
Exactly. The average Y. Y is what we're predicting. Profile picture likes is what we're predicting. And the average is 32. So we have 32 equals, M is our slope. We just found that to be 0.027. And now we need to plug in something for X. So what are we going to plug in for X?
Average.
You know, the other average.
Right, the other average. The average for the number of friends. So 840. And plus B.
Well,
So now we have everything filled in except our one unknown. So we can solve for B by multiplying 0.027 and 840 and then subtracting that from 32. And what do I get for B?
9.6.
9.6. So we have our slope, we have our y-intercept, and now when it said find the regression equation, we can write our regression equation as y equals 0.027, our slope, x plus 9.6, our y-intercept. So this is our final answer. This is our regression equation.
I have a question.
Yes.
So, wait a minute. So, why did we use the point of averages again? The average. Oh, wait a minute. Is that the only point we know?
Right. So here we're not given a list of numbers, the
Yeah.
list of observations of the profile picture likes and the number of friends. So when we're not given those lists of numbers, the point that we know is always going to be on the regression line is just the average of y and the average of x, otherwise known as the point of averages. Yes, Wenli?
For the intercept, does that 9.6, what does it really mean? Is it like when I have 0 friends, I have like 9.6 likes automatically?
Right, so that is the
That's kinda
interpretation of the y-intercept. Here, it doesn't really make sense. If you had no friends, you couldn't really have anyone like your profile picture. But in general, the y-intercept is where that regression line crosses the y-axis. And sometimes it doesn't make sense, sometimes it does. In this case, it does not.
Just
So
based on where the
the
other points
slope
are.
would mean then that the slope means for each, so x is the number of friends, right?
Correct. X is the number of friends, Y is the profile.
So then, so it means for each extra friend, you're gonna get 0.027 of a like?
Yes, that is true. So for
That's
every
like-
increase in friends, for each friend you get, you're gonna get 0.027 more likes. Are there any other questions? All right, sounds good. So in part A, we just found a regression equation. And now in part B, we want to know that if my mom has 100 friends, how many likes will she have on her profile picture? But before we do that, let's look at this equation and remember what exactly Y and X are. Because sometimes it's confusing to remember if Y is the profile picture likes or the number of friends. So let's rewrite this equation using our actual variables. So Y is what we're predicting. So in this problem, what are we predicting again?
Of the likes.
The likes.
The number of likes,
Right, so let's write this as likes equals the same slope, 0.027, times X. And so if Y is likes, X must be the number of friends plus our Y intercept. So now we've just rewritten this regression equation, plugging in what our actual Y and X are. So now let's go back to the problem. We know that my mom has 100 friends. So where we see friends in this equation, we're going to plug in 100. So we have likes equals 0.027 times friends. Again, we have 100 friends here, plus our Y-intercept of 9.6. So now we just have likes equals, and then an equation that we can put into our calculator and solve. So what do I end up getting for likes?
12.3.
12.3, and then if we round to the nearest whole number, what would that be?
12.
12. So using our regression equation, we're predicting that if someone has 100 friends, they will have about 12 likes on their profile picture. Any questions? Jackie?
So if we had gone back to how we were doing this on like exam 1, would it have given us a different answer if I converted 100 to a z-score and used R to figure out the z-score for likes? And then
No.
get the value?
These two methods that we've learned, the using z-scores and multiplying by R and converting back to a value, and using this regression equation will give you the exact same answer. It's just a matter of preference, whichever one you want to use.
Oh.
It should give you the same answer.
Wow, that's pretty cool.
All right, thank you for watching.